Academy Foundation presents the first law, paving a simple path. From basic mechanics through thermodynamics and special relativity to how space-time works. Let's take baby steps. Newton's law of uniformity states that an object at rest or in motion shall remain that way until acted upon by another force. The field of work is our background, the relatively free space and other things in that space like the player. The object in play is our unit in context. Together, they are the total potential. Our unit remains unchanged until the player acts on the ball to convey a complex increment of change in the system. He did not create this energy, it was already in him as part of the field of work. That increment of change affects the potential position and at some point conveys back to the working field. The energy is not destroyed, it simply changes form. Relativistic means the momentum of the ball unit is now subject to rules of proportion and dilation. We are seeking details about the space-time variables shown here as constants. For that, we need to go to the second part of the first law. U prime means the ball value is dependent on the context. du means the distribution of that complex change is now scaled into the energy definition of the unit ball. It shifts independent perspective from context to the ball. Every active transfer of value is a combination of linear and angular values, making this increment complex. Kinetic and discrete definitions depend on the complex input. I color-coded D so you can see it does different things. In the denominator, it is declaring U the unit scale given value in the U prime context. Again, du is the independent form, where U prime is the dependent form. In the numerator, the letter D is saying one variable transforms into another. For example, linear transforms by rotation into angular, or pressure into volume. Heat is the combination of temperature and entropy that describes the distance between things and their rate of independent action. Low entropy means a group of things share the same motion. When the ball was kicked, its motion became independent from the static potential. Its internal structure of atoms, or potentially the axes of its spaces, can also move independently. It can burst from too much linear impact, for example. This is easier than it looks. Dilation sets mass equivalent to seconds squared. Simply remove the units and temperature becomes linear meters of x, and entropy becomes angular meters of y. Manifolds are contextually shaped spaces. Newton's ladder uses translation to convey the energy between the ends. X here is a simple linear path. Y is an angular representation of entropy. The ball acts independently of the field along an x trajectory made possible by rotating out of the bouncing angular effect. Y is more obvious as vibrational flexion, trying to separate the configurations of the ball to act more independently. There are two rotational motions shown here conserving heat. Condensation converts X as linear volume evaporating into Y as angular flow in clouds. Precipitation and runoff convert linear flow into angular volume. X is still a linear thermal effect, whether it is describing a line or a volume. Likewise, Y is an angular entropy effect, whether that describes a line or a volume. We usually think of waves as traveling to convey energy away from a source. A conserved cycle, like the heat cycle, is a standing wave. It keeps the energy local by circling in one spot, providing background temperature and pressure. Our working spaces are invariably standing. The most common form of this is the background temperature and pressure of free space. This space consists of standing waves. Its motion is localized to the point that, in effect, nothing is happening. Don't let all the water, dirt, or life fool you. There are also players within that background. The background enables them to function as discrete things. The discrete things have their own spaces. Thermodynamics outright acknowledges two types of space, pressure and volume. And as with kinetic spaces, these easily convey to manifold axes. These manifolds obey hypersphere rules that are too complex for this topic. To keep it simple, R acts as a converging surface containing Z as a diverging volume. Z is equivalent to the Ricci volume in Einstein's field equation. Their interaction is a distribution space mixed relative to entropy called a gluon. The skin on the ball is R, creating a linear surface tension holding an angular volume of air. The hardness of the ball depends on a balance between the Z volume and its surface. As we saw with conservation of heat, kinetics variables have discrete perspectives. Discrete spaces have kinetics perspectives. The lack of diversity leaves the ball vulnerable to bursting. Now we can assemble our spaces semi-independent of time. In any moment, all spaces and their dilations affect the distribution in time, and its flow are defined. Only the flow is missing. Nothing is changed. No, I didn't forget about the shape of the universe. CMB defines the standing waves of free space. Discrete things in context are constantly changing their values, and the distribution is observed by the linear effect of time on the propagation of light. Then there is Euler's solution that explains propagation of free space. That's right, the first law just keeps giving. In the interests of public health, we'll save this for another video. Quantum relativity conceptualizes advanced topics in established physics to provide educational and practical tools. Our biggest problems in physics are human, specifically too much information and no accurate standardization of the concepts. Basically, advanced physics needs an introductory class to put it all together. Remember to subscribe and stay tuned for other educational videos. Thank you.